I'm Kickmeier-Rust, and I'm with the University of Teacher Education in St. Gallen here in Switzerland. And I want to very briefly present you our approach to assessment and personalization in serious games. Now, why is assessment and personalization so very important specifically for serious games?
It's important because the learning curve isn't the same for everyone. Some climb it very easily, some fail, some do not even try. And this is true for general educational settings, and it holds even more true for serious games. If you have a huge virtual environment where you're more or less left alone. So what we did in the past was to develop an approach called micro-learning spaces, which originated from a theory called competence-based knowledge space theory, which was part of a number of intelligent tutoring systems, and we advanced the approach over the years. Uh, in essence, the approach looks into the natural structure and the natural relationships between human aptitude, competencies, skills, whatever. And it distinguishes a latent dimension, the dimension of human knowledge, and the observable performance dimension.
So basically what we're doing is we try to decompose a domain of knowledge relevant for a serious game and identify the tiny little pieces of aptitude, knowledge, skills, competencies involved in that domain. By the example of mathematics, we have the competency to add numbers, subtract numbers, multiply numbers, divide numbers, and maybe to solve simple equations. And what we do in the next step is we try to identify the natural path of learning in that domain. And we start from the most simple competency to add numbers. We have the competency to multiply numbers. And what we're saying is adding numbers is a prerequisite to learn multiplying numbers. Subtracting numbers is not necessarily a prerequisite. Then we have the competency to divide numbers, and we say dividing numbers requires the understanding of multiplying numbers and therefore also the competency of adding numbers, and we say subtracting is also a prerequisite to learn how to divide numbers. And finally, the competency to solve simple equations requires all the skills down here.
And from the Surma's relation, we can derive the so-called competency structure or competence space. And this is basically the collection of all possible states a person can be in. There might be a person who has absolutely none of the competencies involved in the domain. Or there might be a person, by the former example, who can add numbers, but nothing else. There might be a person who can add and multiply numbers, but there might be no person who can multiply numbers but not add numbers. And now we can formally link the competency structure, the competencies of the domain to the tasks, the challenges, the game situation, the learning objects, the test items we have. And by this means, we can establish the so-called competency structure or competency space. We also can add other formal structures to that construct. Here we have the example of problem spaces. Problem spaces define a starting state and an end state, and they define a number of rules. Here, the Tower of Hanoi, you have three disks, and your goal is to shift all the three disks from one pile to another. And there are two basic rules. You're only allowed to shift one disk at a time, and you're only allowed to place a smaller disk upon a larger one. And this gives a structure, a formal structure of the problem-solving process. We can apply that principle for the domain of a serious game. And what we are doing is basically we layer all the various formal structures upon another, and this provides the game with some sort of understanding about the domain, about the learner, about the problem-solving processes required in a certain game, challenges, items, situations, and enables the game to provide the learner with tailored feedback, tailored hinting, tailored learning support. And I want to show you an example how that approach is applied in a serious game. The example is a game called Fian's Quest, which was developed in a European project called 80 Days. The game uses geography for an age range of about 12 to 14, and the story goes like one night an alien lands with a spaceship in the backyard of the player, and this alien, his name is Fian, he is an intergalactic information scout. Together, player and Fian, they're supposed to harvest, find information about our planet, and they do that by flying around with the spaceship of the alien, and in the various places there are some landmarks, capital cities, where the spaceship can stop and they can beam down and accomplish certain challenges.
The river Danube has broadened. I fear this might not be a good sign.
I don't like that. I'm scared, Fian.
Is it always that dangerous on your planet?
This is one of the many challenges in the game. This is a flood simulation. You can try out various actions of interventions to the environment and their effect on the damages a flood might make. So you can reforest areas. You can reduce the ceiling of the soil, increase it, and there are many options you can take, and then you can simulate the effects of a flood.
Okay, now what are the advantages of doing all that? The great thing is we have a formal model, knowledge, motivation, the story, the problem-solving process, in a form that an autonomous computer system, like a game, can work with it. So in the gaming episodes, the game can acquire autonomously a certain level of understanding about the competencies a student holds, his performance in problem solving, motivational states, and his or her progress through the game. And based on that, we can provide the student with very tailored, very individualized support in terms of feedback, in terms of hints, in terms of game pacing, in terms of sequencing certain events in the game. And this, in the end, makes a smart game. And in the past, we made a lot of studies investigating the effectiveness of such types of approaches. And basically, what we and other research groups found was that adaptive games outperform non-adaptive games each and every time. So basically, what we propose is a very simple yet effective approach to provide in-game assessment and adaptation. And if you're interested in, you might check out further links, and our research papers might be quite interesting. So thank you very much. Bye.